Here's a Hewlett-Packard audio analyzer I bought a couple of days ago. It's the 8903 audio analyzer. It comprises of an AC audio voltmeter, distortion, synad, and signal-to-noise ratio measurements. It was sold as, well, he didn't actually state what it was sold as, but it was, you could read in between the lines, he just bought it and was selling it on, hadn't really any understanding how it was working. I powered it up, seeing I've been messing around with it for a while. It works to a fashion, I suppose, but it's not working correctly. At the moment, if you look at the display, I'm generating 100 Hertz frequency from its internal oscillator and feeding it back into the amplifier's input and measuring total harmonic distortion. And the distortion at the moment is measuring 5%, which is, well, it's way out of spec by 100 times. It's interesting enough to see that if you actually put the frequency on the oscilloscope, you can see quite a lot of sort of, it almost looks like clipping, but it's not clipping. If you reduce the drive of the amplifier, the waveform's still not absolutely flat topped, but at the top of the sine wave is sort of, I don't know, it just looks like there's a problem with it's like a DC offset, or I don't know what it is, but it's both sides of the waveform, on the positive and the negative side. If you increase to 1 kilohertz, if you turn 1 kilohertz, increase to 1 kilohertz, the distortion drops to there you go, 1.5%. Now it's a bit variable actually. Sometimes it will actually drop down to sort of quite a significantly lower number, sort of 0.5%. Frequency 10 kilohertz. You see the distortion drops down to still out of spec, but it's much closer. And you can see here that the frequency is not right either. For some reason, 10 kilohertz is only showing up at 9.93. And that's a bit variable as well. That was okay earlier on, but it's now out of spec. What I've done is I have actually fed in a signal from my Philips audio generator up the top there. Now if you feed that in to the back of the, because all the connections on this unit unfortunately are on the back, so we're feeding the signal in, and that's a 50 Hertz signal fed into the Hewlett-Packard, so that's about 50 Hertz. There you go. You notice the distortion is 0.5%, which is probably what you'd expect for the Philips signal generator. It's obviously 1,000 times better than the Hewlett-Packard's internal generator, but that does actually prove that the measuring side is probably okay. You can't really verify that until we've got it up and fully working. So it looks to me like there's a problem with the oscillator side of this generator. It's distorting at low frequencies, and it seems to be distorting all the time now. There aren't many electrolytic capacitors in there. I've had a look through, and there's nothing I can see that would cause a problem. There are a few tantalums, but none of them are getting warm, and everything looks okay. There's no tantalum leaking out of any of the capacitors, so it could be a sort of like a leaky transistor. I've had a quick look on the internet, and there are mentions of distortions with this generators, particularly at low frequencies, and caused, well, one chap reckons it's caused by a leaky transistor on the oscillator board. So I'm going to have to go through that. They're all FETs, unfortunately, so they're going to be a bit trickier to sort of try and work out which one's causing the problem. But as you can see there, the distortion is down to sort of 0.4%. That increased the frequency slightly. That's a, yeah, it's pretty constant really. It works quite well. It would be a nice meter if it, well, very useful for plotting out flat frequency responses of amplifiers and things. If we can get it to work properly. That's your AC volt output from the generator I'm putting in at the moment. Obviously there's your frequency, there's your sample rate. It shows the sample period with this flashing LED here. You've got various bandpass filters. You've got a high pass filter at 400 Hertz, and you've got various low pass filters, 80 kilohertz and 30 kilohertz. probably most of the time I use the 30 kilohertz one, which is absolutely fine for audio work. It's got a sweep generator, so what you can do is you can set a sweep and it will plot out the output voltage. So you feed the output of this generator into an amplifier and take the output of the amplifier and feed it back into the input, and this will plot the output response. It will show you the response of the amplifier. Obviously a perfectly flat response is what you're looking for in an audio amplifier, but this will show up any anomalies on the frequency response. Most amplifiers have a bit of a frequency response shift. That's fairly normal, typical drop off above 20 kilohertz and below about 50 hertz usually. What else will it do? It'll do signal to noise ratio, which would be great. And basically how you set that up is you set it up to do a signal to noise ratio burst. So you feed in a signal, it puts in a signal, then it mutes the signal, it looks at the response, and it feeds the signal back in, and it takes the differential and works out the signal to noise ratio. But that won't work properly until the rest of the generator's working fine. If you look inside, you've got various plug-in boards, typical with Hewlett-Packard stuff of its era. If you want board 3, you go to the orange board, which is the standard designation for 3. You've got the very early sort of logic stuff here with these old orange LEDs flashing away, showing the processor sampling away. Power supplies at the back here. I've had a check through that. All the caps look fine. Linear regulator power supply here, so it's all sort of very clean output waveforms. There's a couple of LEDs at the back there showing that the rails are up. And they're non-adjustable, which is a bit of a shame because one of the 15 and the -15 rails are slightly offset. I don't think that's a problem. It could be a result of a leaky or a shorted transistor, I don't know yet. Yeah, and this board here at the back here is the interface board for the GBIB or the HPIB, which is the general interface bus. Probably won't be using that. That's the main processor. And then you've got some measurement boards here, so they're quite nicely organised. A measurement board, you've got an oscillator board, which will be the problem. We'll have to have a look at that later on. Let's see if we can work out if any of these transistors are leaky. Quite nicely laid out, typical sort of 80s style. And it's nice actually, because unlike a lot of the HP stuff, it hasn't got a fan whirling away inside it, so it's silent in operation, which is what you really need for an audio generator. Unfortunately, the connectors are all on the back, which is also a shame because a lot of them came with the front. But it does look like there is a possibility to let's get a torch to mount a front panel BNCs, and you can see just down there. You see that just below where that orange wire is? There's a hole. There's a cutout for the BNC, so I might be able to mount the front panel to BNCs. But let's see if we can get it actually working. Will be my first point of call, really. But yeah, it's sort of functioning to a degree. Anyone's got any ideas of what possibly could be wrong with this generator, I'd be really grateful if you could let me know, and I'll have a go at getting it running properly. But yeah, thanks for watching, and hopefully we'll get some more updates on how it performs.